doing some sort of virtual office hours for our genetics class, and I thought I'd start with a super easy problem from one of the old exams that pertains to sex-linked inheritance. I think I'm streaming on Twitch right now and recording it, not actually just blathering to myself. I don't really have a clue if this is working, but we shall soon see. I'm also doing this in my office, and next door Dr. Newsmer is having an incredibly noisy conversation with one of his postdocs, so we'll be able to listen in on that as we do this as well. I'm working on this problem in Photoshop so I can kind of digitally write on the exam problem and kind of show you what I'm thinking, so that's why the window looks the way it does. So just in terms of getting set up here, I feel like it's going to be useful to kind of track, since this is a sex-linked problem, the male and female components of the problem. And so I hope that by doing that I didn't just screw up your view of things, but at any rate, I'm going to work in two different colors here. Generally speaking, when I'm writing in blue, it'll be related to the male part of the problem, and red would be the female part of the problem. So let's have a look at what's going on. This is from, I think it was a 2014 exam. It's a very boring problem with not much in the way of video game references or gaming references, but as you'll see from future exams, I remedy that quite frequently. Just to remind you, we covered X-linked inheritance or sex-linked inheritance in class, and one of the examples that we used was red-green color blindness in humans. Now this problem actually embeds a great deal of assumed knowledge. And if you struggled with just the basic concepts, for example, of XY sex determination, you're kind of in trouble for a problem like this. So let's just walk our way through it, and we'll see what we come up with. Red-green color blindness is an X-linked trait in humans. It's actually X-linked recessive. You should know that by coming to class. We went over it in a fair amount of detail. When you're working with sex-linked genetics problems, it's critically important that you keep track of not only the alleles of the individual, but the sex chromosomes that the alleles come on. So let's have a look at that and kind of set up what we know about this particular problem. We've got three individuals here. So the first is Sally. Now we just infer from her name, I suppose, that Sally is female. And one of the things that you can do, and I'm giving myself some space so I can do the allelic notation in a second, Sally has two X chromosomes because she's female. This is a really good example of that embedded knowledge I was talking about. If you didn't follow that piece of the lecture, you're going to be in trouble. Now, what we really need to know is what Sally's genotype is. And because she's a female, she has two X chromosomes, we're not entirely sure, except that I say up here that Sally's mother, and we're going to call her S-mother or smother. That's not funny at all. Also a female. She's colorblind. That's what it says right here. So what we know immediately, because this is an X-linked recessive trait, Sally's mother, smother, carries two alleles that cause color blindness. We denote those with the lowercase c as a superscript. Now, what do we know about Sally? Well, we know she has normal vision, that's stated right here, which means she must have at least one wild-type allele. And now remember, the wild-type allele is denoted with a plus sign a lot of times in genetics. But we also know that Sally's mother was homozygous for the color blindness allele, so Sally must have received from her mom one of these two X chromosomes, and for the purposes of this problem, they are identical. So we can infer that Sally is a heterozygous carrier for the color blindness allele. Normal vision, but a carrier. Okay, so those are two of the three named people in the problem. Let's have a look at Ray. Ray is Sally's husband. And we know he is male. And because you understand the XY chromosomal sex determination system, you know that Ray has an X and a Y chromosome for the purposes of this problem. Now we state up here, Ray has normal vision. And recall that in males, the Y chromosome, especially for X-linked traits, carries no genetic information that would be allelic to that which is carried on the X. And so we know Ray has normal vision, so this would be a plus. There's nothing on the Y chromosome. The Y chromosome is a wasteland of stuff that determines maleness and not much else. Okay? So what we've really done here is converted this prose into genetic nomenclature, and that's really the important first step in almost every sex-linked inheritance problem that you're going to see in this class. So we've got Sally, we've got Ray. Now, what you're going to see with this particular problem, I'm going to ask you to do something mechanical, which is to draw the Punnett square. And then I'm going to ask you to interpret. In particular, I'm going to ask you to interpret for an attorney, and it'll become obvious why an attorney is involved in a second. So, Ray's attorney has contacted you, you being the geneticist, to refute or substantiate Sally's claim that both of their current children, one son and one daughter, who are colorblind, are that way because colorblindness runs in her side of the family. This is the claim that she's making. And technically speaking, the claim is true. Colorblindness does run in her side of the family because her mother was colorblind. So it seems legit. But let's have a closer look. So let's do the Punnett square. So we'll start with Sally on the top, and here's where the red and blue will come in handy. Okay? Here's Sally's possible gametes with respect to the sex chromosomes and the colorblindness allele. She can make a gamete that contains a wild-type X, or a gamete that contains an X carrying the colorblindness allele. Now Ray can produce a gamete with a wild-type X, or a gamete with a Y chromosome, and that carries no genetic information relevant to the colorblindness trait. So let's box this out, and hopefully I've given myself enough room. Now what we have to do is track what kinds of kids they could have. Now recall, they have one son who is colorblind, so that son must be XCY. And they have one daughter who is also colorblind. She must be XCXC. So let's have a look at this. So in this case, this putative daughter would get this X chromosome from Sally and this X chromosome from Ray. They would have normal vision. Here, we get an X chromosome from Ray and an X chromosome containing the colorblindness allele from Sally. Okay? Now, both of these daughters would have normal vision. One would be a carrier here, and one would be homozygous for the wild-type allele. Let's have a look at the sons. So in this case, the son is going to inherit the X wild-type X from mom, and a Y, because he is a son, from the dad. And here, a son would inherit the colorblindness X from mom and a Y from dad. Notice I'm not using the name Ray here. Okay, so an attorney's involved, and you're asked to comment on whether or not colorblindness running in the family could explain a pattern of births with these two individuals where they had a son and a daughter, both of whom were colorblind. Okay. It seems kind of complicated, but it really isn't. It's quite simple. I want to draw your attention to this colorblind daughter. Look over here, the two possible genotypes of daughters that could be produced in this cross. Do you see any homozygous colorblind daughters here? It's not possible. Now, it is possible to have this colorblind son. That's no problem. But it's not possible to have this colorblind daughter with this particular cross. Now, there's a variety of biological explanations for this. One would be that this individual is actually Ray's daughter, but carries a new mutation that caused her to be colorblind. Now, the probability of that actually being the case is roughly equivalent to the probability of Ray winning the lottery. Truly not likely. So, the most plausible explanation, especially when we deal with things in human genetics here, is that this particular daughter is a result of an extramarital. My handwriting is terrible. It's going to be terrible on this tablet online. It's terrible in the classroom. It's terrible with pen and paper. You're going to have to just get used to that. Okay? So the only way for Sally to have a colorblind daughter is if she had a daughter with a colorblind man who could give her this other X chromosome. Ray could not. So that would be the interpretation. And so to answer this question completely, you'd have to show this Punnett square and then state something, in one sentence, for example, that says the daughter is unlikely to be Ray's child, or something similar. Okay, so that's a super boring, vanilla example of a problem on an old exam pertaining to sex-linked inheritance.